All right, mathematicians, this is the final section of Unit 4 on Similarity and Transformations, Section 4.6. Our essential question: when a figure is translated, reflected, rotated, or dilated in the plane, is the image always similar to the original figure? Our objectives are that mathematicians will be able to perform similarity transformations and describe similarity transformations. All right, so let's start off with some vocabulary and key points. So performing similarity transformations means a dilation is a transformation that preserves shape but not size. So a dilation is a non-rigid motion. Rigid motion, remember, means to preserve side lengths and angle measures. So if a dilation does not preserve same size, then that means it is a non-rigid motion. So a similarity transformation is a dilation, a composition of dilations, or a composition of rigid motion and dilations. Only angle measures are preserved, not side lengths. And similar figures are same shape but not necessarily the same size. All right, so you're going to need some graph paper for the examples in these notes. All right, so let's take a look at example 1, performing a similarity transformation. Take a moment to graph triangle ABC with the following vertices, and then we will perform the following transformations. First, we will translate, and we will move 5 to the right and up 1. Then we will dilate from the center at 2, -1 with a scale factor of 2. All right, to start, we will translate. So A prime will end up at 1, 2. B prime will end up at 3, 3. And C prime will end up at 3, 2. And then next, we will need to dilate. So that's where we draw in our lines from center location at 2, -1. So I've plotted that point. Go ahead and plot it yourself. And we want to connect lines to each vertex from that center point. So figure out your slope. So I'll start with A prime. The slope is resulting in a -3. And we want to double that scale factor. So we will go up 3 and left 1 from there. And then to get the slope from P to B prime, you get a result of +4. So that means we'll go up 1 more 4 and over 1 to the right. And then the last slope from P to C prime results in a +3. So we will double that as well. So your dilation should be resulting in this figure. So when you double all of these values, let's see what that looks like. I go up 3, left 1, and then I go 1 more as the double. 1, 2, 3, left 1, plot. Then for the 4, I would go from the center of dilation, go up 1, 2, 3, 4, over 1, and then go another time because it's doubled. So 1, 2, 3, 4, over 1, plot B prime. And then for C, it's going to be a slope of 3 from the point of dilation. So I go up 1, 2, 3, over 1, and then I'm going to double that. So I go up 1, 2, 3, over to the right 1, plot. So that's how you get your dilated image using slope. All right, example 2, we're going to graph triangle MNP at the following vertices, and then its image after the similarity transformation. All right, this time we're going to dilate from center 2, 2 with a scale factor of 1/2. And then that new image will be then dilated again from center 1, 3 with a scale factor of 3. All right, so we'll start with the first dilation at center 2, 2. So plot your point at 2, 2. And then a scale factor of 1/2. So that means we're going to divide by 2. So multiplying by 1/2 and dividing by 2 are the same thing. So our first slope from C to M is going to be figured out by counting up and over. So we go from the center point to 2. So we count up 1, 2, and then left 1, 2, 3, 4, 5, 6, 7, 8. So it looks like our slope is 2 over negative 8, so half of that would be 1 over 4. So we go from here, the center point, go up 1, left 4, and plot. So m prime lands at negative 2, 3. Next, slope from C to N. We figure that out, and that's 2 over negative 6, so half of that would be 1/3. So from our center point, we go up 1 over left 3. Plot, and there's point N prime located at negative 1, 3. Then our last coordinate is figured out by figuring out the slope from C to P, which is 4 divided by 0, so half of that is going to be 2 divided by 0. And when I say half, I'm taking half of each movement, the x and the y movement, not multiplying by 1/2 necessarily. So I go up 2 and plot, there's P prime located at 2, 4. All right, let's take a look at our second dilation at center 1, 5 and a scale factor of 3. So plot the point 1, 5, and then we want to connect lines from that center of dilation to each vertex of the prime figure. So we figure out each slope. All right, so the first slope we'll figure out is from C to M prime, which is negative 2 divided by negative 3. We want to triple that, so we multiply 3 times the 2 to get 6, and 3 times the 3 to get 9. All right, so that puts M prime, double prime at negative 8, negative 1 location. So let's see how we figured that out. So we went 6 over 9. So that means we go left 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 1, 2, 3, 4, 5, 6, and plot. So a negative direction left and a negative direction down is a result of a positive slope. So it works out either way. All right, next slope is going to be from C to N prime. And that slope results in a negative 2 divided by negative 2. And we want to triple that 2 for both the numerator and denominator, resulting in a 6 over 6. So from the point center dilation, we go down 1, 2, 3, 4, 5, 6, left 1, 2, 3, 4, 5, 6, plot. So N double prime lands at negative 5, negative 1. All right, and our last slope that we can figure out is from C to P prime, which results in a negative 1 over 1. Triple both those values and get a negative 3 over 3. Let's see how we graph that. Going from center of dilation, we'll go right 1, 2, 3, and down 1, 2, 3, resulting at P double prime 4, 2. So that's how you dilate using slope. And this was a composition of dilations. So at this point, we've learned multiple versions of a composition of transformations. And that concludes our transformations unit. Bring any clarifying questions in and be ready to practice any and all types of transformations.